Hello everyone, my name is Fernanda Scarcella and I'm here today to show you how to use LLM4Series, a Python library we developed to make time series forecasting with large language models more accessible and simple. So let's get started. Well, this notebook is available in our GitHub page, and we'll start this tutorial by cloning and installing the repository from our GitHub page, and you can install it with pip or in development mode, that is your choice, okay? And then we'll set up our API keys. So it depends on the LLM provider you're going to use. You can run models locally in your machine with LM Studio too. But in this tutorial, I'm using the GPT-5 from OpenAI model and the DeepSeek model. So I'm setting up those API keys as environment variables. Now let's head to the data preprocessing steps. So we load our data with the function read file, and we are loading the CSV called the baseline. This dataset is available in our GitHub page, and it is the number of passengers that are validated per hour in a baseline. Here we identify the column of the date index. Okay, so here I'm printing it to show you that because the dataset contains one timestamp column and one value column, it understands it as a univariate time series. So it represents it internally as what's so-called unitime series in here. So when we're dealing with time series, we have to handle some quality issues. Two of them are missing values and duplicate timestamps. So we first identify if there are any missing values or duplicate dates. And if there are, we are going to input those values with linear interpolation. So the library provides other methods such as median imputation, mean forward field, and we are going to handle the duplicate dates by getting the sum of those values. So here I did not have any missing values, but I had duplicate stamps and it's all handled, okay? Then we are going to split our data into train and test sets. So identifying the start and end date of our training sets and getting the number of periods I will want to predict our test sets. So to help the time series analysis, so LLM4Series has some built-in visualizations for you to understand your data. So the first is the chart, and you can see the raw data in here and understand its overall pattern. We have the STL decomposition visualization too, that you can understand the underlying patterns of the data, visualizing the transitional and residual components. For further comprehension of the STL decomposition, you can check this link. And finally, we can also view the statistical descriptions such as standard deviation, mean, median, so you can have a quantitative summary of your data. Okay, now let's build our prompts. Good news, you don't have to write it from scratch. LLM4Series builds it for you in a structured way with the prompt function. You just have to pass your training data, the forecast horizon, TS format, and TS type. The same thing, if you want to pass any examples to the prompt, you need to tell what period of your time series you want to use as an example, and the type. The type is the inference strategy. So the LLM4Series provides four different inference strategies. There is few shots, chain of thoughts, zero shot, and chain of thoughts plus few shots. If you want to understand what are those strategies, we provide those descriptions in our paper. And in this tutorial, I'm using the chain of thoughts. That is, we provide a step-by-step reasoning description to the LLMs. We also provide the STL decomposition trend and seasonality values. So that might help the LLM to focus on real patterns rather than just trying to guess. The TS format. So there are a few ways of formatting your series. We provide two different ways. The plain format that explicitly labels each timestamp and observation. It increases token overhead, but it provides clear semantic anchors that might be particularly beneficial for zero-shot reasoning. And the CSV format. And it is highly token efficient, and it might be better if you want to pass longer sequences due to token limitation. The TS type, so there's two ways of representing your numbers, the standard way, the numeric way, or the textual. In the textual, we add spaces between numbers because we have different strategies of tokenization between models, and I'll explain about that a little bit later, okay? Here's our prompt. And you can pass your own templates too. You just want to choose the type for custom and pass your own templates. But I want to inform you something. Our library gets the values to compare with the real ones between out tags. So you need to pass this in your prompt to provide the final forecast inside out tag. So it might not get the real values. It will include only values between those tags. Now let's finally run some experiments. Well, first let's get the GPT-5 from OpenAI performance, okay? So we first initialize the model. We serialize our data with the plain formats and textual type. You choose your own. We get the model response with the predict. We pass our prompt. We want to use the training data and the model temperature. Then we serialize the predicted values just like our training data. And with the line plots, we can visualize the difference between the original values and the forecasted values. With the error metrics implemented in the library, those are the sMAPE, the MAE, and the RMSE, we can understand that the GPT-5 achieved great results, okay? It rocked. So to test and compare different prompts, I will run an experiment now with the custom prompts I had made. So as we can visualize, it is a little bit different than the other one. And with the error metrics, we confirmed that the LLM4Series prompt achieved slightly better results than the custom prompt, which shows how important is the prompt construction, because this is the same data sets, different performance with the same model. We can also test and compare different types. Remember the numeric and the textual types? So it is due to tokenization processes of different models. For example, the GPT family, it tokenizes its sequences into chunks of three. So while models like Quen tokenize it in a different way. So here I have an example. GPT-5 with no spaces tokenizes it this way, while with the spaces it tokenizes the same way as the Quen. So these may affect the model performance and may change the forecasting results. So here we run an experiment. I built in different prompts with the numeric type this time, and the comparison results show that they achieved the same results. That might be because our data set contains only numbers until the 100, so it was not affected by the tokenization of GPT, but you can visualize, you can see different forecasting results with other data sets, okay, with different number ranges. The library also provides a few metadata, the total processing time, input tokens, and output tokens. So this helps you to get a bit of your cost monitoring, to get your budget insights, okay? And we can test and compare different models too. So I'm gonna compare the GPT-5 with the DeepSeek Listener here, the same code, And here, the surprisingly, they achieved the same result. So this is possible. Okay, this is possible. You might want to run those experiments more than once to get trustable results. Okay, so here DeepSeek and GPT-5 are okay. Well, so I've shown you an example in the univariate context, but our library also supports multivariate forecasting. And even good news, I have the code stays basically the same. The only difference is when you are calculating the error metrics, you need to specify the target column, okay? Since now there are more target variables. Here I am running an example with the ETTH2 dataset that is a very common dataset in benchmarking with time series forecasting, and this dataset is also available in our GitHub repository. And the target is the oil temperature column, okay? Here we have great metrics, so it's really similar to the real values, and we can visualize it here that this is the GPT-5 model. It rocks, guys. It's, it's very good. And that's it. Simple as that. That's the whole pipeline. From data preprocessing to model comparison, LLM4Series handles all the complexity, the prompt construction, evaluation, visualization, so you can focus on experimenting and finding what works best for your forecasting problem. So check our repository on GitHub and try it with your own dataset and let us know what you think. Thank you for watching. Bye.